Okay, welcome back. We're going to talk about trigonometric ratios of complementary angles, and here we have is we need to understand what is complementary angles. So complementary angles are angles that add up to 90 degrees. Okay, so angles that add up to 90 degrees. And we're going to use this because since we're talking about angles, we need to look at all kinds of angles, right? We've been looking at different kinds and we need to talk about this. So we'll go into a recap about your basic angles first. So using your basic angles triangle, from here we have that this is 1, 1, and this would be a square root 2 by Pythagoras theorem, and here will be 1, 2, and square root 3. You need to remember this, and you need to also remember that this angle here is 30 degrees. So we can actually do our trigonometric ratios of our basic angles here, which is fairly simple. I wouldn't say that's super hard. And here we have what's this? Okay, opposite over hypotenuse, so this will be half. Sine 45 will be 1 over square root 2. And in this case, sine of 60 degrees would just be square root 3 over 2. We can do the same for cosine theta. So cosine, this will be square root 3 over 2. This will be same thing, 1 over square root 2. And this will be half in this case. Okay, and finally we have tangent. Tangent, it will just simply be opposite over adjacent. So this is 1 over square root 3. And over here, it will be just simply 1. And over here will be square root 3, which is just square root 3 over 1. Okay, so we can see that there are some based on these basic ratios, there are some that are equal to each other. We see that sine 30 degrees is in fact equals to cosine 60 degrees. Correct? So if you look at the this value is equal to this value, we can also say cosine 30 degrees is equals to sine 60 degrees. And we can also say that tangent 45, we can also say the same of sine, sine 45 is equals to cosine 45. But having the same value is actually quite interesting in this case because these angles here, 30 and 60, adds up to 90, right? And you look at throughout all of them, if there are different trigonometric functions, but their angles add up to 90 degrees, we can make a connection here that if I take the sine of 90 degrees minus any angle theta, it is simply going to be cosine theta. Okay, and we can do the same for cosine theta as well. So cosine 90 degrees minus theta will give you sine theta. Last but not least, what about tangent 90 degrees minus theta? Now, if you look at it very carefully, we have here that tangent 30 degrees is equals to 1 over square root 3. And this is in fact equals to 1 over tangent 60 degrees. So we can actually safely say that the tangent of 90 degrees minus theta is simply 1 divided by tangent theta. And that is your 3 unique complementary angles that you need to know for trigonometric functions here. So with that, we're going to go on to a work example where we are given cosine 40 degrees is equals to A, and we're going to express each of them in terms of A. I think the first one is pretty straightforward. We can apply what we learned straight away. Okay, that sine 50 is simply going to be equals to cosine 40 degrees. And you can just straight away directly apply, you don't have to write anything, and you have A. Okay, moving on to the next one, which is tangent negative 50 degrees. We have actually learned that for negative angles, we actually need the help of the quadrants to help us now. So if I draw a quadrant and we want to find where it's negative 50 degrees, it's actually lying in the 4th quadrant, and this angle here is negative 50 degrees. And with that, we can say that the basic angle here is also 50 degrees. The basic angle is equal to 50 degrees. Okay, so with that, what we can do is say that this is simply equals to negative of tangent of the basic angle, which happens to be 50 degrees here as well. And with that, we can write that this is actually the negative of 1 over tangent 40. Now with this being said, it's going to be a little bit tough for us right now because we don't have much information here. Okay, but what we do know is cosine 40 is equals to A. So in the sense, we can actually rewrite this as negative 1 over sine 40 degrees divided by cosine 40 degrees. And this would simply just be negative of cosine 40 degrees divided by tangent 40 degrees. Sorry, why am I saying tangent? It should be sine. Okay, which begs the question now, how are we going to find sine 40 degrees? Not that, it's actually not that hard. In the sense, we must understand that we must use the, okay, one way is to use the quadrant again. I'm going to use this quadrant again. So if I'm talking about cosine 40 degrees, a positive angle right now, okay, so imagine we have a positive angle here of 40 degrees. So this is 40 degrees. Okay, drawing the right angle triangle, we have that cosine style is okay, we have that cosine 40 degrees is simply A. Okay, so cosine 40 degrees A, which means the adjacent over the hypotenuse equals to A. We can also safely say that it might be A units divided by 1 unit. In this sense that we can actually figure out this hypotenuse here, which is simply the square root of 1 square minus A square, which is simply just square root of 1 minus A square. So this is one way to derive this part, and with that we have the opposite in terms of we have sine 40, because sine 40 will naturally just be sine of 40 degrees. Based on this, it will be just simply the opposite, which is square root 1 minus A square divided by 1. But if you divide by 1, it is simply just this value here. So in the sense, this becomes, the answer here is just simply negative A divided by the square root of 1 minus A square. So that's for tangent 50 degrees. Now last one we're going to do is sine 11 over 9 pi. First you need to do some conversion. You must roughly know what's 11 9 pi. So 11 over 9 pi is simply in radian mode. Radians is simply going to be, if we convert it into degree mode, it will simply just be 220 degrees. Now 210 degrees is a very interesting angle. I don't understand why it is giving us this, but if we look at same thing, we will draw what we can draw. Okay, over here this angle lies in the third quadrant. So this falls back to your understanding about all this again. Now 220 degrees, okay, is in fact 180 degrees plus. So this angle we're looking for is here. Okay, 220 degrees is made up of 180 degrees plus 40 degrees. So this would mean that the angle I'm looking for is just here, right? This is a 40 degree angle. Okay, so since sine is in the angle is in the third quadrant, sine is going to be a negative value. So it will simply be the negative of sine 40 degrees. And we have sine 40 degrees, which was square root of 1 minus A square. So this is just simply, okay, I don't think I can express this as 40 degrees. Maybe I need to write this as radian actually. So how do we get 40 degrees in radian? In fact, we said that it was simply 11 over 9 pi radian is equals to 220 degrees, right? So we just simply take 11 over 9. I'll write it here. 11 over 9 pi minus pi. So it's just simply 2 over 9 pi. Okay, so this is in fact equals to 2 over 9 pi. And this is just negative, which is just 40 degrees, right? So it's just negative square root of 1 minus A square. So So that's how you do work these examples, where I give you a initial trigonometry function in terms of a and figure that out. That's it.